Hello, welcome. Let's try to solve another Leetcode problem. 2305. Fair distribution of cookies. You are given an integer array cookies where cookies I donates the number of cookies in the I bag. So this is the cookies, and it is just donates the number of cookies in this bag. So for example, for the first bag there are going to be 8 cookies. For the second bag there are going to be 15 cookies. We also give an integer k that donates the number of children to distribute all the bags of cookies to. Yeah, so normally this k means the number of children. So for example, the number of children is 2. So this is the first children and this is going to be the second children. Yeah, now this children going to select some cookies. Yeah, all the cookies in the same bag must go to the same children and cannot be split up. So for example, this 15 or this 5 cannot be split up. So for example, this 8 cannot be split up to 4 and 4. We cannot do that. So the unfairness of distribution is defined as the maximum total cookies obtained by a single child in the distribution. So we're going to return the minimum of the maximum. Yeah, we're going to return the minimum unfairness of all distributions. So let's just check the first example. So in the first example, we can choose 8, 15, 8 to the first children, so it's going to be 31. And for the second children, we can choose 10 and 30, 10 and 20, so it's going to be 30. And the final answer going to be the minimum of the two, it's going to be maximum of the two. Yeah, so it's going to be 31. Yeah, so this is 31 going to be the final result. So if we didn't choose this, maybe they're going to be 41 or 20, we don't know, but the maximum number going to be 41. But our final return going to be the minimum of all the possible results, so it's going to be 31. Yeah. So how can we solve this problem easily? Let's just check what we are given. The cookie's length is 8, and cookie I is 10 to the power 5, and k is equal to cookie's length maximum. Yeah, so because this cookie's length is only 8, maybe we're going to use backtracking. Yeah, so the idea is that we're going to prepare k buckets. So this going to be k buckets. This is going to be the 0 bucket and the index 1 bucket. So we're going to have such kind of a bucket. Now we just want to drop the cookies into the bucket. So for example, we're going to drop 8 here, and we're going to drop 15 here in this bucket. And maybe for that 10, we're going to drop it here. And for 20, maybe we're going to drop it here. And for the last one, 8, maybe we're going to drop it here. And then we just need to calculate what's going to be the maximum value. So here going to be 31 in total, here 30 in total. So the final result is going to be 31. Yeah, so we're going to just try to simulate the problem like that. So how can we simulate it like that? We just put the cookies into one of the baskets. So definitely we're going to use backtracking. So for the backtracking, we're going to enumerate the cookies, and we're going to check one by one. So for this cookie, we're going to have two decisions. We can put it here, or we can put it there. Yeah. And for the next cookie, we can put it here, or we can put it there. Yeah. So what's going to be the time complexity? So it is the length of the cookies, so the maximum is going to be 8. Yeah. And for each of the time, so it's going to have 8 choices, because there can be 8 buckets maximally. So 8 to the power of 8, it's going to be 2 to the power of 3. 3 times 8, it's going to be 24. So 2 to the power of 24, basically it is okay for this problem. That is why it can pass. Yeah, so definitely we're going to use backtracking to solve the problem. Although there are other ways like the bit set DP, like the set DP, that's going to be a little bit harder and to understand. So currently we're going to use backtracking to solve the problem. Yeah, so we're going to prepare n going to be length of the cookies, and we're going to use we're going to define a bucket. So the bucket is going to be 0 times k, so it's going to be k bucket. So each children going to get a bucket of cookies, and finally we're going to return the maximum of the bucket. So now we're going to define the backtracking. Let's just define it as DFS. So we're going to prepare two variables. So the I going to be the index from 0, and we're going to prepare a current max. So we're going to define a max variable. So if I equal to n, we're gonna update the result. So we're gonna define the self.result. It's gonna be infinity. Yeah, so if I equal to n, so the self.result gonna be the maximum of the self.result with the current max. And now we're gonna give a return because this is a backtracking. So we're gonna prepare a branch. So we're gonna prepare the trimming. Otherwise, otherwise I think we can pass. But we're gonna prepare a trimming for it. So if the current max is more than and equal to the self.result, so basically this means we will just trim it for the tree because that is not possible because currently we find a smaller value for the self.result, but currently we find a bigger value. Definitely we don't need that, so we're gonna branch from here. Yeah. Now we're gonna start the backtracking. So for j in range of k buckets, so for each of the bucket we can have a we can have a decision to take it or not take it. So we're going to use the bucket j. I'm gonna plus equal to, we're gonna decide to take the cookies I, or after backtracking we're gonna minus the cookies I. But in between we're gonna prepare the backtracking, so it's gonna be the DFS with I plus 1. We're gonna go to the next cookie, and we're gonna update the result, so it's gonna be the current max with the bucket j. Because this current max basically it is tracking for the maximum value inside each of the bucket. So here it's gonna be bucket j. So here for each of the DFS, definitely we're gonna have this I, this cookie. So for this cookie, it can go to any of the bucket. So here, this is why we're gonna use a for loop to check if it can go to any of the bucket. So here we start the backtracking. After that, we're gonna minus this cookie. So this means we're gonna just enumerate all the possible cases until we find the minimum. So finally, we're gonna return self.result. But before that, we're gonna call the backtracking. It's gonna be DFS 0 and 0. So this is for the problem. Let me check what is wrong with it. I think we need to check the minimum value. So here gonna be the minimum, and here gonna be maximum. But finally we're gonna choose the minimum possible result. So minimum possible result is of each of the maximum one. As you can see, now it works. Now let me just submit it to check if it works. Now as you can see, it works. Although it is slow, but it works for the backtracking. So even we don't use this kind of trimming, maybe it still works. Because according to the analyze, it should work or not. I don't know, but let's just have a check. It didn't work. So we have to use our trimming. As you can see, it didn't work. So we have to use a trimming to make it work. So for here, basically we're gonna choose the minimum value. So here basically we're gonna choose the maximum value of each of the distributions. So for example, this is one of the one distribution. So this is another distribution. Maybe this value is let's say 5, 6, 7. So this value is 5, 6, 7. Currently we're gonna choose the minimum. Maybe this gonna be the minimum gonna be 5. Maybe we're gonna have another distribution. Now we're gonna have another distribution. Let me just check. So for this one, this is one of the distribution, and the current max is gonna be 7. So currently our result gonna be on 7. Now maybe we're gonna have another distribution. It's gonna be 6, 6, and 6. Now what's gonna be the current max? It's gonna be 6. So the result gonna be updated to 6 because 6 is smaller. This is a smaller distribution. So this is exactly what we are doing. Thank you for watching. See you next time.